the weight distribution of butterflies and elephants is normal, which is given. Two normal distributions will differ from each other if they have a different mean, a different variance, or both. So if two normal distributions can have the same mean and the same standard variance, they become the same distribution. In which case they'll have the same alpha and the same beta. Right? So the point is, can I make these two distributions have the same mean and the same variances? Okay. So first, think of 753. What's the mean of this? 5. So let me subtract 5 from each. So what do I have here? 2. What's the mean of this? 0. What's the mean of this? 2. So think of, what do I get? What's the mean of this? 0. So now, just by subtracting the mean value of each elephant from the weights of all elephants, and just by subtracting the mean value of mean weight of all butterflies from the weight of each butterfly, I can make the two distributions have the same mean. Now the only difference is this standard deviations are different. Right? The standard deviations are different. Okay. Suppose sigma square E is the variance of elephant weights. Yeah? Sigma square B be the variance of butterfly weights. Right? Sigma square E is the variance of elephant weights. Sigma square B is the variance of butterfly weights. Remember a very important property. If I multiply each value of x by alpha, then variance of alpha x becomes alpha square variance of x. You remember that? Yes. Multiply each value of x by 1 for alpha. First exercise. So variance of alpha x is nothing but alpha square variance of x. Right? So, if I divided each value of x, right? If I divided each value of x by the standard deviation of x and looked at this variance, what will this variance be? What will the variance of 1 upon alpha x? What is the variance of 1 upon alpha x? 1 by alpha square variance of x. Variance of alpha is alpha square variance of x. So variance of x by alpha is 1 upon alpha square variance of x. So variance of x by sigma x will be what? 1 upon sigma square x into variance of x. But what is the variance of x? Sigma square x. So this will be 1 upon sigma square x into sigma square x is 1. Right? So, first trick. If I take the weight of all elephants and subtract from it the mean weight of all elephants, the mean becomes 0. Now the resultant quantity, if I divide it by the standard deviation of elephant weights, the quantity will also have a variance of 1. So this is a very important idea, so listen carefully. The weight of elephants is normally distributed with some mean mu and some variance sigma square e. मैं क्या करता हूँ? Each value of x से पहले mu को subtract करता हूँ. So I am subtracting the mean weight of all elephants from the weight of each elephant. अभी इसका mean क्या होगा? 0. हर इस क्वांटिटी को I divide by the standard deviation of elephant weights. Yeah. All these quantity divided by the standard deviation of elephant weights. What will be the variance of the resultant quantity? 1. The variance of the resultant quantity will be 1. The distribution is still normal. Similarly, butterflies के weight में से I subtract from the weight of each butterfly the mean weight of all butterflies. What will be the mean of this new series? 0. Now, this series I divide by the standard deviation of butterfly weights. What is the variance of this series? 1. So the elephant weight series can be rescaled to have mean 0 variance 1. The butterfly series can be had to have mean 0 variance 1. So it becomes two normal distributions. They have the same mean and the same variance. So they will have the same distributions. So they will have the same alpha and beta.
Yeah, but the series is different.
Series is different. That doesn't matter because they have the same distribution. Because two normal distributions differ from each other just because the only two reasons they differ from each other. They have different means and different variance. So you can get the mean and the variance identical. Right? Then the distributions become the same. So they'll have the same alpha and the same beta. They'll have the same alpha and the same beta. In fact, therefore this new distribution is called the standard normal distribution. Okay, it's called the standard normal distribution. It's going to be a very important distribution for us. Right, so let's break for a cup of tea. We'll come back and look at how useful this idea is.